Hi, everyone. Thank you so much for joining us today. My name is Elena Martinez. I'm the technical manager for this session entitled Conducting Synthesis Analysis in Agriculture and Nutrition. Will be chaired today by our facilitators, Pierre Marion and Shannon Schisler from the International Initiative for Impact Evaluation, or 3IE. Thank you so much for joining us for ANH 2024. We look forward to a robust and interactive session today. So before I pass it back to Pierre, I have just a few technical announcements to make our experience as smooth as possible. So this session is being recorded and will be posted on the ANH Academy website following the conference. All participants have been muted as you entered the call, but please introduce yourself in the chat box. You can let us know your name, where you're joining us from, and what organization you work with. I see a few people have already turned on their webcams. Thank you so much. We encourage everyone to turn on your video if possible during this session. If you have any questions, you can share them in the chat box during the session. And if you're experiencing any technical issues, please do check your audio settings and your internet connection. And you can also message me during the session and we'll try to solve your problems. So thank you so much. And I'm going to pass it over to Pierre Marion to get the session started.
Thank you very much. So my name is Pierre Marion. Hopefully you can see my screen. I'll put this in presentation mode. So so my name is Pierre Marion. I'm a research associate at 3IE. So 3IE is the International Initiative for Impact Evaluation. So I'll be leading this learning lab with Shannon. Shannon, do you want to introduce yourself?
Yeah, sure. Shannon Schisler. I'm a lead evaluation specialist with 3IE, primarily working on the quantitative pieces of our work, so meta-analysis, data management and cleaning, and the like. So very much looking forward to discussing data with you today.
Thank you for that. So just to introduce ourselves a bit more, just share some information about 3IE. So 3IE is a global leader so we produce, we quality assure, and we synthesize rigorous evidence. So we work on studies and reviews that examine what works, for whom, why, and at what cost in lower and middle income countries. So LMICs, we'll be using that quite a bit in this presentation. So 3IE has published nearly 400 studies, and it also manages the Development Evidence Portal, which is the world's most comprehensive repository of rigorous evidence on what works in international development. So it's a very useful tool. I highly recommend going onto the Development Evidence Portal to identify any relevant study to your research. So the aim, the structure of this 2-hour session, so a bit less than 2-hour session, is not to give you a lecture. We'll try to make it interesting, interactive, and useful. Shannon will be talking about the value of a systematic review, the steps of a systematic review. I'll be talking about the results of a systematic review Shannon and I worked on recently. So that's the fourth item, and then we'll have two sessions. The second half of the session, will be 2 exercises, and so there'll be initially some information on the tools, and then we'll ask you to ask a few questions, and we'll then discuss answers. So these are 2 important steps of a systematic review, specifically identifying the relevant studies to include or exclude based on the systematic review inclusion criteria, so what we call the screening, and then the second part would be how to manage the data and deriving effect sizes for the analysis. And in between all this, we'll be using Menti to sort of, well, initially we'll be using it for some some questions to sort of start, well, to build your interest in these topics and to get an idea of your knowledge on these topics. And we'll be using it in the 2 parts, and then at the end of this session. So just in terms of the learning outcomes, so we will obviously discuss on what is synthesis work, what is a systematic review, why we do it, the steps, and also be talking about the gold standards. So yeah, so so learning about the gold standards, gold standard methodology to identify relevant studies, so a part of the screening, and then understand and apply methods for data management. So hopefully at the end of the session, you will be familiar with these 2 parts of systematic review. So let's turn to Menti before Shannon before Shannon presents. Sorry, I guess I need to show how to access it. Yeah, so if you could go to Menti. If you could go to Menti at this with this code, or click on the link depending on what device you're using, or even the QR code if you can access that. And so so take that code, and maybe I think maybe it'd be useful if someone could copy that in the chat. And then I'm going to turn to the Menti. Yeah, so so the question is, how many impact evaluations have been conducted since the start of the 20th century in development economics? So be interested to hear your what you think the answer is. I'm gonna give another 30 seconds. So it's obviously either you know it or you don't know it, so just give it a try. Yeah, and you see the code. If you still have trouble accessing, you see the code up here. And so, yeah, okay. And so the answer was more than 11,000. The second question to start us off is, what is one of the main goals of systematic reviews? So subjectively review the literature, synthesize the available evidence, or count the number of studies which indicate that a particular intervention type affects an outcome type. I guess I'll put the timer, put another 30 seconds. So as you answer these questions, these are concepts that we'll be covering in the presentation. Yeah, so yeah, you mostly got that right. And the final question is, what is the percentage of policy reports which are never cited? So more than 20%, more than 50%, more than 80%. And this is actually to give you more specific detail. We're talking about World Bank policy reports, but this is probably relevant for also research, academic research, or other working papers. Yeah. Yeah. One more second. Okay, so it's actually more than 80%. So unfortunately, a lot of a lot of work is not being cited. And yeah, so and then I think, yeah, the next question is obviously for the next part. So now I'm going to turn to, we're going to turn to the value of systematic reviews, and yeah, Shannon will be talking about this part. Sorry, okay.
Great. Thank you so much, Pierre. So I think as we saw indicated by the more than 11,000 impact evaluations since 2000, we have quite an information explosion on our hands. And so we know that the number of articles actually doubles every year. And the number of journals doubles every 15 years. And that seems to be increasing as there's more pay-to-play actors. And so the problem for practitioners is, how do you then find the evidence that you need? Oh, sound is not coming. Can others hear me?
I can hear you.
Okay, so it may just be a particular issue. Sorry about that. So yes, how do policymakers, practitioners find the relevant available evidence? How do they possibly like maintain awareness of everything that's being put out into the universe? And then how can they possibly, in their very, very busy lives, read and process all of the information that's available? And so really the solution is to find a way to summarize the evidence in a systematic and unbiased way to help answer policy questions. So of course, on the left side here is just a picture of sort of the initial information explosion. I can't even imagine what this would look like now. I don't think it could even be stacked in many rooms at this point. But also our development evidence portal, which I think actually this particular graph is a bit old, because I think we're over 13,000 since this graph of maybe 3 months ago. So we know that the trend is continuing, right? That we continue to find more and more literature available to answer policy questions related to international development across all sectors. Next slide, please. So how did we used to do this? How did we used to summarize what was available? Of course, I'm sure all of us at one point in our lives have done a narrative literature review. But that often involves cherry picking certain studies that help support our point, and does not create new knowledge. It just synthesizes knowledge that already exists. One of the answers to the question of what synthesis is was just counting how many studies say that something works, right? That is known as vote counting. That was also a previous way that folks synthesized. But what we found was that actually that could give you a false positive, essentially. Like you could think something works based on counting how many studies are significant versus non-significant. But if you actually put those studies into a weighted meta-analysis, then you may actually get a completely different answer. And so we know that vote counting is not a reliable approach to an unbiased answer when synthesizing evidence. And then, of course, the test of significance, p less than 0.05. So we don't have information on the size of the effect, and it's not really a very interesting answer to get, right? Like we want to know what works, we want to know how well it works, we want to know for whom and why. And so just having knowledge of what is significant is not really that interesting. Next slide, please. So what do we do now? We have a couple of different approaches. You may have some familiarity with our evidence maps, where we essentially map across interventions and outcomes in a matrix format online, in an interactive way where you can click on different bubbles and see the size of different bodies of evidence, both primary evidence and also systematic review evidence. And then also we use systematic review. So the evidence maps only answer questions about how much evidence there is and where we have evidence saturation versus where we have evidence gaps, where we could potentially meaningfully fill those gaps with new impact evaluation studies, or where there's synthesis gaps. So we have a lot of impact evaluation studies, but nobody has synthesized them yet. And so there is some space to make a meaningful contribution. Whereas systematic reviews can answer different questions around what interventions are most effective, questions around context. So for different populations or groups of people, how do the effects differ? And so really what we're going to focus on today is the systematic review portion. Okay, next slide. So I think one of the values certainly of systematic reviews in particular is that we often see conflicting findings, right? So and on this slide you'll see some stories that were posted in the same outlet, so 2 from Time and 2 from Mail Online, within a few months of each other, saying coffee is bad for you or that it's good for you. And so how do we decide like what the actual truth is, right, when we have conflicting findings? Next slide. In addition to the problem of conflicting findings, we also know that research needs to be more accessible. And so synthesis is another way to make that research more accessible. So this is the World Bank report that Pierre mentioned in the first initial questions. So they found that actually 1/3 of their policy reports had never been downloaded at all, and that 87% of those reports have never been cited. And so, you know, research reports are often long and they're technical and they're not easily accessible, but they might have really useful nuggets of information or findings that could be super important. And so synthesis, particularly systematic reviews, find a way to make sure that that knowledge is combined with other existing knowledge in a way that's digestible quickly and easily to a policymaker to help them make important decisions about resource allocation, about program design and implementation. And so that's really where we see the value of synthesis. Next slide. Just another example of conflicting findings. This is the relationship between different food ingredients and cancer. And of course, 80% of ingredients from a random selection of studies has been linked to cancer or cancer risk in some way. But oftentimes, these studies can be based on weak statistical evidence. If you just look at single studies, as you can see here, if I were to just pick out a single study, I could find evidence that a particular food item causes cancer. I could find evidence that it doesn't. And so we don't want to cherry pick. We need to critically look at these studies, appraise them to see if there is potential risk for bias in the estimates. It's a really important step in determining how trustworthy the evidence is and how reliable the conclusions might be. So most literature reviews just describe existing knowledge, but the idea of synthesis is really to create new knowledge. So taking these studies, weighting them by their precision, and coming up with an overall average weighted effect to tell you really on what side of the line each thing would fall. Next slide, please. So the primary goals of synthesis are really to, as I mentioned, promote evidence-informed decision-making. So distilling important information into a way that's accessible to policymakers, where they have access to the best available evidence, where they understand the quality of the evidence and the implications of that for how trustworthy the conclusions are. Of course, we we don't want to spend resources unnecessarily doing things that have already been done. So if we know that an intervention doesn't work, or we have enough evidence that it does work, then we probably want to allocate resources to something else. And then, of course, informing future programming research. So what gaps do we need to fill? What programs are most effective and for whom? Those are all values of synthesis. And so we generally start with all of these disparate individual manuscripts, and we distill them into qualitative syntheses, evidence gap maps, or quantitative syntheses, or sometimes a combination of those things. And then really a critical piece for 3IE in particular is to make sure that those become public goods. So all of our syntheses are available as a public good, and they're available freely on our website, and we encourage folks to use those that are available when doing your own work. Next slide. So just briefly going to go through the steps of the synthesis and highlight where we will be focusing the activities today. So of course, systematic reviews use scientific, transparent, reproducible methods to assess and synthesize the results from multiple studies to answer a specific question. And that can be a question about intervention effectiveness. It can be a question about barriers and facilitators to program implementation, design. Questions about cost. So what is the most cost-effective intervention to use in a particular population? Whatever the question, the idea is that systematic reviews are unbiased. So we are very comprehensive in our search. We cover all of the literature, both academic and gray literature. We don't impose language restrictions. We generally, if resources allow, try to search back to 1990 so that we're capturing all of the impact evaluations available. We also use rigorous methods. As I mentioned, we always publish a protocol, which we follow to make our work transparent and reproducible. We critically appraise every impact evaluation that we include in our systematic reviews, and that ensures that we are highlighting the most high quality evidence. And when conclusions are based on low quality evidence, we make sure that we highlight that for the policymaker. Again, our methods are clear, they're reproducible, they're based on international gold standards, which are published and agreed by several synthesis bodies, including Cochrane and the Campbell collaboration. And then, as I mentioned, we always make sure in particular that our outputs are available freely as public goods. And wherever possible, we when we get resources to do so, update these as new evidence becomes available. So in general, our process has several steps. First and foremost, and actually quite important, is stakeholder engagement. You want to make sure that you're answering the question of interest to the end user and that the end product is most useful to that user. And so here we engage with our donors, we engage with an advisory group to ensure that we are framing the question correctly, that we are looking at the right interventions and outcomes. And so that process is really important in us developing our protocol, which our stakeholders usually read and comment on, and give us feedback prior to our publication. And then, of course, we publish that protocol. We then search for published and unpublished studies, so academic and gray literature. And we will often search multiple databases. So we may search 9 academic databases and 30 institutional repositories for a single review, because of course, as I mentioned, we want to be as comprehensive as possible. We develop our inclusion criteria as part of the protocol development, and we use those inclusion criteria to determine ultimately which studies will be included in the synthesis. And for any studies that are included, we appraise them. We appraise their quality. Have they appropriately accounted for confounding, for selection bias? Are there problems with attrition? Are there problems with p-hacking? Like, have they published a protocol? Have they reported on all the outcomes that they have said they were going to report on? Or is there some potential p-hacking happening? We then extract relevant metadata and quantitative data from every included study. And then we synthesize that evidence either quantitatively or qualitatively, depending on the research question and the type of information that we have extracted. And then we provide from that evidence and from the output, we'll provide research implications and policy implications of our results. So two things that we'll focus on today will be the screening stage, where we screen against the study inclusion criteria. And then I guess somewhere between data extraction and synthesis of evidence, there is a piece where we really need to look critically at the data, and then we need to calculate effect sizes appropriately in order to be able to synthesize our body of evidence. So next, Pierre will go through some of the findings and learnings from a systematic review that we've been doing for, I guess, the last 2 years on agricultural output market interventions. And then he will lead us through the exercise of screening studies. And then I'll see you again at the end for some more information about data. Over to you, Pierre.
Yeah, thank you very much. And so this is actually the largest systematic review that 3IE has done in its history. So I think obviously correct me if I'm wrong, Shannon, but it was a very large and I think it's the latest systematic review of 3IE. So I'm just gonna briefly go through it. I won't spend too much time. The context, why we did it, and then briefly some results, interesting results we found. So market access is considered to be market access has been used by development actors to address poverty. And so in the last 2 decades, there's been a significant rise in the number of these types of interventions. So to better integrate poor and remote farmers into markets. And so as a result of this greater focus of development actors on these type of interventions, the number of research published, unpublished on the effects of these interventions has also increased. And so when you look at other previous systematic reviews or non-systematic reviews on this topic, they're not as comprehensive as the one we did. So we focus on a broader definition of agricultural output market interventions. We used a greater number of databases for the search of relevant studies. And I think also our systematic review was the first one to actually synthesize the effects in a quantitative way, not a narrative or qualitative way. So we focused on 5 types of output market access interventions. And so for each intervention type, we have a chapter. So we have 5 chapters. So we focus on farm to market transport infrastructure, output market information, new marketplaces and alternative marketing opportunities, contract farming, and improved storage infrastructure and technology interventions. And so, as I was saying at the beginning, we have. So I guess here I listed the research questions that we tried to answer, and as I was saying at the beginning, this is what are the effects for whom, at what cost, and and so and I guess the third one is not sorry, the third one, it wasn't mentioned at the beginning. So how reliable are the findings? So we critically appraised, as Shannon was saying, critically appraised the existing studies to determine what the level of risk of bias of these included studies. Also, yeah, I guess necessarily if you're doing a systematic review, you're going to identify where the gaps in the literature, are located. So just to give some brief information on the search, how we started from the databases, academic databases, the grey literature, and then we did some citation tracking. So within the studies in academic databases and grey literature, we searched for studies that were referenced or cited by other studies. And so we had more than 60,000 records. After we removed the duplicates, we had more than 52,000. And so then using a mix of machine learning and human screening, and I guess we'll be talking about that in one of the two exercises, we identified 2,400 relevant studies. And yeah, sorry, we used title and abstract to reduce from that 52,000 2,400. For about a bit more than 100 studies, we could not find the full text. And then at this point, we did full text screening of the 2,345 studies. And so we obtained 288 impact evaluations, and 150 studies were linked to these 288 impact evaluations. So we included 438 studies after the full text screening. So now some information on the results that we found across the different chapters. So the first chapter, farm to market transport infrastructure. So these are initiatives to improve transport infrastructure of farmers, facilitating access to market so that they can sell their products on the market. So the vast majority were domestic transport infrastructure, so roads, in some cases bridges, but most of the time roads. And so we found 81 studies across 40 interventions in 29 countries. And so this graph or this picture here shows the effect of this intervention type across the relevant outcomes that we were considering. So intermediate outcomes, agricultural production outcomes, immediate outcomes, then intermediate outcomes, off-farm, non-farm outcomes, and then welfare outcomes. And so in order to understand the colors here, so white indicates that we did not find relevant studies, or very few studies, less than 3 studies. So you should interpret this as a gap in the literature. The gray indicates that the evidence does not definitively indicate or precisely indicate that these interventions led to an improvement in these outcomes. So we found a non-statistically significant overall effect, average overall effect. And then the different shades of green indicate the magnitude of the positive effect. And so in these cases, it was statistically significant. So the data or the effects are quite precise to say that there was a positive impact. And so yeah, you can see that there was quite a moderate impact on farm investment. So there was greater investments following these roads, improvements in yields, and then total income and wealth. Then moving on to the second chapter, so this was outcome market information intervention. So this was providing information, so for example, prices and then farmers could decide where would be the best place to sell their products. To summarize it very briefly, so we found 81 studies in 47 interventions, 19 countries, and so you see here additional gaps and areas where the effects weren't statistically significant. We found quite a moderate effect on labor market outcomes. Then in terms of creating new marketplaces, this was physical marketplaces and arranged offers between buyers and producers. Here we see some of these effects here. So maybe in for purpose of time, I won't go through all of this, but so obviously if you want to see precisely the effects, you can go back to this slide, and obviously Shannon has shared the link to the published paper in the chat. So there's quite a few positive effects here for this chapter. Similarly for contract farming, so this is where we found the most studies, but still we found quite a lot of gaps in literature. So 193 studies across 36 countries. And then finally for improved storage infrastructure and technology intervention. So obviously there the aim is to reduce losses, food losses, and then farmers can sell on the markets. There we found the smallest number across the 5 chapters, 23 studies, and so as you expect, there was a reduction in so positive effects. There was a reduction in crop loss, and that then had other impacts as shown here. I just want to very briefly talk to you about the limitations of our systematic review. So so as you saw, we did find some positive effects across intervention types on outcomes, but even though this was the largest systematic review for these combinations of interventions and outcomes, in some cases the number is quite low. So this positive effect is based on a small number of effects. Publication bias may be a concern, so authors may be discouraged to publish a lack of a positive effect of these interventions. In this systematic review, though, we did include obviously unpublished papers, and that also contributed to the final results. A lot of the high risk of bias for quite a few, for maybe a small majority of the included studies. So the effect may not actually reflect what happened in the field. And then these interventions are often combined with other intervention types. So it's not always possible to attribute the effect of a specific intervention on these outcomes. And then finally, just in terms of the implications, so the results of this systematic review showed that these output market interventions have a positive effect along the causal chain, so are beneficial for farmers. The data is less clear for food and nutrition outcomes, so there we can't, the results don't indicate clearly that these interventions led to positive effects. And then in terms of implications for researchers, so there's definitely gaps in the literature, as are highlighted, and more work is needed to conduct research that is not subject to high risk of bias, so addressing confounding and selection biases. Cost data was lacking in vast majority of studies, so that's obviously very important for policymakers. And yeah, very unevenly distributed evidence across interventions, outcomes, geography, etc. So now let's turn to the two small exercises that we'll do, and it will take the most of the remaining time of this presentation. So as I said, there'll be two exercises, one on identifying the relevant studies for the systematic review. So whether to include or exclude a specific study based on the systematic review inclusion criteria. So I guess from now on, I'll be calling it screening. And then the second one will be on which Shannon will talk to you about. It will be on data management and how to derive the effect sizes for your systematic review. So obviously that stage would follow this one after you have when you've identified your included studies. So in terms of the steps of screening, again, so to identify the studies to include, exclude, and then when I was showing my search, the graphic of the search for the systematic review earlier, you probably saw that there was two stages. So I'll get to that in a bit, but in terms of the screening criteria, the criteria that we use at 3IE is summarized with this acronym PICOS. So population, intervention, comparison, outcomes, and study design. And so a study would be included if it satisfies all of these criteria. It has the relevant population, relevant intervention, relevant comparison, outcomes, and study design. And I guess the gold standard for screening is to follow two stages. So first of all, we do the screening at title and abstract, TAS, and then at full text. So title and abstract, you rely on simply the title and abstract to determine whether it should be excluded or excluded. But obviously, if there's not enough information, you would automatically include it, and then you would look at the full text, whether it should be included in the systematic review. So in order for it to be the gold standard, to follow the gold standard method, you need to do a double screening and then discussions to resolve any disagreements between the two people that are doing the screening. So just very briefly, I'll be showing here the criteria that we actually used for the systematic review I was presenting earlier. So in terms of the population, and I guess this is relevant for all of 3IE's synthesis work, is that we focus on low and middle income countries. So that's the population that we're interested in. The interventions, as I discussed, there was the 5 different chapters. So transport infrastructure, output market information, new marketplaces, contract farming, and storage infrastructure. So that's our interventions. And in terms of our comparison, so we want a group that's not affected by that's not subject to the intervention, or it could receive it in the future, or it could have a different intervention. The outcomes, so they are listed here. So that was the different columns on the graph I was showing you across the 5 different chapters. And then the study designs. So we want to include in our systematic review studies that are are produced that have the lowest possible risk of bias. So we include randomized or non-randomized designs. In order to attribute the intervention, the effect to the intervention. So as I was saying before, we need two independent screeners. Include studies regardless on how the results are presented. And it's very important to document the process in order for, as I was saying, the reconciliation and then the discussion on any disagreements for that to be effective. That's obviously very important. So just in terms of the specifics of the two different stages, so title and screening at title and abstract, and then screening at full text. So for both stages, we follow sort of a screening priority question. So it's based on a prioritization and sequential exclusion approach. And as I was saying, if we don't have enough information in the title and abstract, it would automatically proceed to screening at full text, and then we would follow this same method. So if it passes title and abstract screening, TAS, we then look at the study in the full text of the study, and the only difference is that we also consider the outcomes of the study. So we do not focus on the outcomes at title and abstract screening. So this is just a representation of the questions you would need to answer in the screening. And as I was saying, each question, these questions are listed in a specific order. And so this is what we call priority screening, priority question screening. So if you answer, if this study is focused on high income country, you would answer yes, and you would not focus on the following questions. You would just exclude high income country, and it wouldn't be considered in the systematic review. Then you would focus on the study design. Is it a relevant study design? Is it a relevant study design? The following question is, has the study been published prior to 2000? And obviously, as Shannon was saying, sometimes it can be after 1990 or I guess 89. Does the study include an intervention that is consistent? So this is the I of our PICOs. And then finally, this would only be relevant for full text screening. Does it include an outcome that is relevant? So the O of our PICOs. So now we're gonna turn to you. We're gonna ask you to do to try out this screening process and to learn about it by actually doing it. So there'll be five studies to screen at title and abstract. So I shouldn't have put screening there, but yeah, 5 TAS, 1 FTS, and it'd be based on the PICOs and the screening priority questions I've just shown. So the first title and abstract screening, we'll do it together, and then you'll have 5 minutes to do 4 on your own, and then we can discuss. And we'll be using the Menti as earlier to answer. And finally, we'll do 1 study at FTS, full text screening, and there you have more time because obviously it takes longer to do a full text screening. And again, we'll discuss the answer using Menti. Yeah. So in terms of the first example, so I'm gonna share with you. So hopefully Okay, yeah, I need to close this, sorry. So I'm going to share the document that's here. And so this is, as you open it, as you download it and then open it, you'll see that it's exactly the same as what I presented earlier. So you'll see the PICOs here, this table, and you'll see the screening questions. So this should guide you on how to determine whether this study should be included at title and abstract screening. So yeah, I tend to get back to the beginning. So yeah. Yeah. So yeah, so this is the first one to focus on, and maybe just take a few seconds to read it through, and then based on what I've just presented, then we can discuss whether you think this study, based on the PICOs I've shared with you, should be included or excluded at title and abstract screening. So I'm going to turn to the Menti. And so, yeah, sorry, I'll just get this ready. Yeah, so I'm going to go back to the presentation and so, yeah, so then the Menti is here. Yeah, so have a look. And when you think you have the answer, let's turn to the Menti. So I'll keep it a bit longer because you probably didn't have time to read it, but yeah, so we got the title, we got the abstract and the year of publication, and based on this, this is all the data we need to determine whether it should be included or excluded at TAS. So if you had trouble, tell me if you had trouble accessing the document. So maybe I'll wait a few more seconds. Should have access to it, but maybe it's too hard, or yeah, okay, see one answer. And so maybe it's best if I stay here because obviously you don't need to see, we can talk about the results in a bit, but so maybe I'll move on. Yeah, so some of you have indicated include, and that's the correct answer. And so let's try and understand why this is the case. So I'll probably just stay like this because it might take too much trouble to go from the presentation to the Menti. So yeah, so the elements highlighted in green are the elements that help us make a decision, and in this case, to help us determine that we should include this study at title and abstract screening. So we see in terms of the country, so this is Bangladesh, definitely a low and middle income country. In terms of the intervention, we focus on transport intervention, so rural roads. In terms of comparison, so there we don't have the information on comparison, but we don't assume that it doesn't if the information is not there. In terms of the outcomes, we don't focus on outcomes title and abstract screening, and then in terms of the study design, that information is not there. So there's no information that goes against our PICOs, so we would include this. So that was the first example. Now, if we turn to the second part of this exercise, well, if we turn to the 4 other TAS examples, I'll be sharing a second document. And so here you have 4 other cases. 4 other cases, and again, we'll be spend the next 5 minutes going through each of these 4 cases. And so for each case, it should take about a minute or less than a minute. And then we can answer together, or you can share your answers in the Menti. Yeah, I think initially I see the question there. I think initially, obviously some coders are better than the others, but I think it should take about 8 papers per hour at full text screening. So you could do, about 50 or 60 in a day. Whereas for title and abstract screening, you would take a minute, bit more than a minute to determine whether it should be included or excluded. So hopefully you have access to the document, and you can give it a try in the Menti. So I'm just thinking of time. Okay, yeah, should be fine, I think. Yeah, so I'm just checking. So yeah, so let's actually focus on one at a time. I think that's what we had agreed. Yeah, Shannon. So yeah, I'll give you 30 more seconds on this one, and then we'll be doing them one by one, showing you the answers, and then going back to the Menti. So yeah, so I think if I remember correctly, yeah, you got that one correct. And so if we look at specifically this one, so this was question 5 in the Menti. Yeah, so again, elements in green indicate that, yeah, so that's the P, the participants were this a lower middle income country. Then yeah, there's no information on well, sorry, yeah, you should obviously follow the order of the questions. And if I guess I'll open it myself. Yeah, I think the second question, as you I think, yeah, sorry, the second question is linked to the study. Yeah, that's what I thought, the study design. And yeah, so you correctly identified that here we're not talking about randomized or non-randomized. So what we also call it experimental and quasi-experimental designs. Here we're using key informant interviews and focal group discussions. So it's obviously a qualitative analysis. So yeah, you correctly identified that it should be excluded based on the study design. Yeah, it also put that the intervention type is not relevant, because I think it was linked to I can't remember what it was linked to, but yeah, in any case, it wasn't part of the five types of interventions that is in the the intervention types that we're considering here. So then in terms of, so let's go back to the Menti. So let's look at the third case. So that should be on the second page of the Word document, of the last Word document I shared. So I'll give you a minute. Yeah, so that's probably a minute. Yeah, so you correctly identified that it should be excluded as it's focusing on a high income country. So yeah, show that to presentation. And so this case, so you see here that it's focused on on South Korea. So that's, I think if I remember correctly, that's the first question in the list. So we wouldn't consider the following questions. We would exclude title and abstract based on this. And then also the intervention is not relevant. So then in terms of the third one, which is, well, it's actually the fourth one here. So here it is. Yeah. And sorry, I'll just time it quickly. So we get a minute. Oh, yeah. So yeah, so the answer here is actually outcome. The intervention is not relevant. Someone put that it was year of publication. So in our priority screening, we're considering studies published after 2000. So this would be includable. But here they're focusing on conservation strategies. So it's not part of one of the 5 types of interventions that we're focusing on in this systematic view. But yeah, it is focusing on the right population, right area, and I don't think there's any information on the study design. So then finally, the last case. Yeah.
Pierre, can we give 2 minutes for this one? Maybe people don't have quite enough time, and then let's leave this abstract up until that 2 minutes is over.
Yep. Yeah, perfect. I'll just yeah, okay, I'll just time it. Yeah, you can answer that, but yeah, 2 minutes. Okay, perfect. Okay, good. See some answers. Oh, sorry, I guess I should go back to the, yeah, a few more seconds. Okay, so I guess I should stop it there. So yeah, so you all got the correct answer. And so yeah, this should be includable. So here there's actually quite a lot of information on each aspect of the PCOS. So we got first of all the country, Tanzania, and the intervention is linked to storage, which is relevant. The comparison group, we have a randomized control trial, so that's fine. Then the outcomes, we're not interested in the title and abstract screening, and then randomized control trial. So that's why we so that's obviously relevant study design. So that's why we include it. Then if we then go to the FTS, so the second stage of screening. So this is full text screening. So I'm going to share with you another document. And so as you open this document, just to explain, and I guess I can show it as well. This is part of a text. It's actually part of the study we've just included at title and abstract screening. And so what I've done, I didn't share the full paper because it would take too long, but I have here the key parts, I guess, of the study. And so don't take the time to read every word, but maybe try and identify the areas that may be relevant in order to determine whether this study should be included at full text screening. So just now we determined that it should be included at title and abstract screening, but now it's moved on to the FTS stage, and now we want to determine whether it should be included in our systematic view. So so hopefully you can have access to it. I'll move on to the answers for this FTS. And yeah, so let's spend 5 minutes to try and read through this document, and then we can discuss whether this should be included at full text screening. So yeah, it's 42. And if you don't have access to the document, maybe I can show it here and then slowly scroll down during the 5 minutes. If you do have access to this document, don't hesitate to. So you can obviously download it, and then you can highlight specific parts that you think are relevant in terms of the PCOS. So the PCOS and the questions. So the participants, intervention, comparison, outcomes, and study design. So I guess in order to do this correctly, you would need to identify whether all of those aspects criteria are met in order to include it in past the full text screening, and therefore in the systematic review. So I'm gonna scroll down a bit. Maybe I'll stay here a bit longer.
Could you zoom in a bit more, Pierre?
Yeah.
Thanks.
But yeah, so let's go to the to your answers. So I'm going to show. Let's see. This is just yeah, just a thumbs up. So yeah, you would include this this study at full text. So you mostly got it right. So now I'm going to show you the study, the same document, but with highlighted the parts of the text that are relevant to determine whether it should be included or excluded at FTS. And so I guess I'll also share it in the need to close it. So it's loading, and so yeah, so this is what I consider to be the relevant parts of this text to determine that it should be included. It's a shame it doesn't show them. So yeah, so this thing is anything above, no. So yeah, so I obviously if you're doing the full text screening, you would read all these elements, and yeah, so here we see. So yeah, I had highlighted other things, but it's not showing for some reason. So yeah, so first thing I had highlighted was Tanzania. So this is the P. Sorry, this is the P. This is our participants. It's in a low and middle income country. So that satisfies the first criteria. Then in terms of the interventions, we're talking about storage technology. So this is a relevant part, and it describes how they or what this intervention was about. So that so then in terms of the comparison and intervention and study design, this part here gives all that information. So it's a randomized control trial, so necessarily there's a control group, so there's a comparison. Again, it's talking about storage infrastructure, and randomized control trial is it's an experimental study design. So you would meet all of those three criterias. And so yeah, the only thing that's missing now is the outcome. And so these other aspects just support that is the right intervention, the right study design. And so yeah, so then there's information on the outcomes in the empirical model sections. And so we're talking about sales of agricultural production, which is part of our relevant outcomes. And we see here, sorry, sales, yeah. So here, and then the equation just confirms that we're looking at intervention, that we're looking at storage infrastructure. So it seems pretty clear here now that it should be included, and obviously, obviously when you're doing full text screening, you would need to not just rely on the first paragraph, not just on the method. You actually look whether there's specific estimates, specific effects of this intervention on the relevant outcomes. And yeah, and so the conclusion again just repeats the information that they had, as you would expect, in the main body of the text. So that's full text screening. Obviously, you would do that on many different studies. And so that gives you a taste of what it is to do full text screening. I think maybe please ask any questions in the chat. Maybe for purpose of time, we should move on to the second part of the so the second exercise that Shannon will be focusing on, which, as we said, is on data management and deriving effect sizes for the analysis. And then I guess I'll make it bigger.
Great, thanks, Pierre, and thanks to everyone asking some really great questions in the chat. Please keep them coming. I know 2 hours is a very small amount of time to try to cover everything. I see a question about AI tools, so maybe while Pierre's preparing the slideshow, I can talk a little bit about that. Currently, we primarily use this in the screening stage. So in order to shorten the timelines, we try as much as possible to do the stages in parallel rather than sequentially. And so one thing that machine learning allows us to do is to, after we've coded about the first 1,000, as Pierre showed, we had like 52,000 titles and abstracts after deduplication. And after we've coded about the first 1,000 or so, we will start to use what is called a priority screener. So what it does is it takes all of the coding that we've done and it predicts the probability for all of the rest of the papers, the probability that we're going to include it at the next stage. And then it gives us those papers to screen first, which is really helpful because it sort of front loads the ones that are most likely to be included at the next stage so that we can then move them to the next stage. So we can essentially have simultaneously people doing title and abstract screening. We can have a team of people doing full text screening. And then as soon as something gets passed through full text, we can have a third team that's already doing data extraction on the included studies while the screening is still ongoing. And so that is super helpful. And I think there's also a question about the timeline. So of course, our ability to use machine learning, particularly on the screening phase, because we do get tens of thousands of studies for almost every project that we have, is really important for our timelines. We do need that extra time that affords us. We will, of course, there is another screening function where we might not screen the bottom, say 20%. So if there's like a 20% or less chance that we're going to include it, depending on resources, budget, timeline, we might make that our cutoff and say, we're not going to even look at any studies under 20%, except for our random quality check to make sure that actually, so maybe 5 or 10% of those studies we will look at to make sure that that was a correct assumption by the algorithm. I think the other key with the timeline, so as I mentioned, part of our reason for doing it this way is to be able to do things in parallel. But to be able to do all of these stages in parallel, you need to have a really large team of people, right? So if there's only 2 people doing the review, then you're going to have to do one thing at a time. And so I think another thing that's pretty critical to our process and particularly to doing things more rapidly is to be able to rely on a very large team, not only of staff, but also we have quite a large pool of consultants from around the world that participate in these screening tests with us. And probably about every 6 months or so, we do a posting inviting folks to apply to be a part of that consultant pool to do this type of work, the screening process work. So if that's of interest to anyone, please check our website every so often. We'll have another posting for that. Okay, so I think, Pierre, if you can man the chat, I think there's a question about the programs that we use, but maybe while you're answering those, I will move on in the slideshow. So if you can just go to our next slide. Okay, so we've screened all of the studies. We've decided that this is the universe of studies that are includable in our review. And then we have to start data extraction. And so very much like screening, the gold standards for data extraction are that two people extract independently and then reconcile to make sure that all of their answers match. And if they don't match, they either have to come to an agreement or they have to ask a third team member to weigh in to make a decision. So we will extract things like study characteristics, of course, all of the aspects of the intervention, including how long the intervention went for, how long between when the intervention ended and the data was measured. We want everything we can get about the study design, about the control group, and then of course, quite importantly, everything about the outcome, including the effect size itself. And so that might be presented in the form of a regression coefficient or an odds ratio or risk ratio and incidence rates. They could just present a standardized mean difference, or they may not give you anything at all. They may just give you a 2x2 frequency table. But all of these things can be extracted and then used to derive an effect size essentially in a common metric. Okay, next slide, please. So this is like my favorite part because I feel like I put my detective hat on when I'm looking at a data set, and I do everything I can to make sure that our data is as good as possible because of course garbage in creates garbage out. And so we really need to make sure that our data is accurate. Of course, with any work done by humans, there is room for human error. And so a lot of the work that we do on the back end after the data extraction is really just to make sure that we're catching as many of those potential errors as possible, to make sure that our data is reflective of the primary studies that we have included. So we're going to work with a very small data set today, but I think our last data set had something like 3,700 effect sizes. So you can imagine that these can become quite large. And so there's a lot of opportunities for error, particularly when you're working with very large teams and you have a lot of different people. You have to make sure that, there's not coder drift happening. And so you're sort of keeping an eye the whole time on the data set to make sure that things are being done consistently across all of your different coders, and that you're catching those human errors that are inevitable when we do this kind of work. Next slide, please. Okay, so as I mentioned, effect sizes are reported in the individual studies through a variety of ways. So it really depends on the sector. I think most often come across regression coefficients, but I think for certainly certain aspects of health, if you're looking at things like mortality or certain aspects of education, when you're looking at things like dropouts, you may be more likely to have odds ratios or risk ratios as the main metric that's reported. But in any event, it's not only rare, but I've never had it happen in any of my work at 3IE where they're all comparable across all of our included studies. Like there are always studies that are giving different metrics of things. But the great news is that all of the metrics are convertible between one another. So once you've decided on a metric that makes the most sense to you, to your project, or perhaps the one that's most used in your data. So if 80% of my effect sizes are being reported as regressions, then that's probably the metric that I'm going to convert the remaining 20% to. But of course, we need to make sure that the unit is the same across all of the studies in order to be able to put them into a meta-analysis. And then, of course, we have to choose a formula for calculating the effect sizes, because generally you get a regression coefficient or an odds ratio, and then you will convert them to, for example, a standardized mean difference, which is what we typically do. But the formula that you select is going to depend on the data that's there. So you can only use the data that's available in the study to create or calculate your effect size. So that's really what's going to tell you what formula that you need to use at the end of the day. Next slide. Okay, so we're going to look at a very small study. Here, are these out of order? Because I thought I was going to be going through the data stuff first.
So now I can share the Excel documents.
No, there was 2 slides on the data management tips that I was going to cover
Yeah.
before the exercise.
I think
Oh.
yeah, give me a second. I moved them to the bottom, but I can very quickly bring them back. Hopefully they're here. Yeah. Okay. Sorry about
Thank you.
this.
So I think, you know, if you have any aspirations or do any work with this area, I think these are really useful because 3IE has done about 40 systematic reviews at this point. And these tips reflect things that we have seen in the course of these 40 systematic reviews. So I think one really key take home for me is that when you are doing this work, you always need to read the table notes. So you expect data to be presented a certain way, but I think you'll find after reading thousands and thousands of studies that it's actually quite inconsistent. And so in this first example here, we had a t-value calculated of 1,876. And if you are quantitatively minded, you may know that that is a absolutely crazy number. I typically my rule of thumb is to look at any t-values that are greater than 10 as potentially problematic. So certainly when I saw this t-value, I expected that there was quite a large problem. And so I think in this case, they were presenting the p-values in parentheses instead of the standard errors. So typically people present their standard errors in parentheses. For some reason in this particular manuscript, they were presenting the p-value instead. And so you can see that the p-value is quite a lot smaller than the standard error. In another case, there was a table note that said that all of the effects were multiplied by 100. And this was not taken into account. And so we ended up with a t-value of 700. Again, a completely out of bounds number. Next example. And then, of course, there are things that just happen because of typos. And so that's another thing that we try to catch through this sort of detective work phase. And so here, seeing a t-value of -293, again, immediate red flag. And when we went back, and so typically what happens is we flag that these are crazy numbers, that these are like very, very highly unlikely to be true. And then we have to go back to the original study and we have to look again at the data. And in this case, the coder had typed -51 instead of -0.051. And so that made a huge difference, as you can see in the t-value. And then another one that we hadn't thought about or considered at all until I think that this review that Pierre and I have worked on is that not everybody's using the same version of Excel, right? So people's Excels are in different languages, and in some language versions of Excel, there is no decimal points, and the decimal points are replaced by commas. And so in this case, there was a coder that did not have their Excel in the English version. And so the t-value should have been 3.983 and instead was coded as 3,983. And of course, that was the reason that we had an incorrect. So make sure that all of your coders are using the same version in the same language so that you can avoid things like this. So is that all of the, there's more. There's ways to do that. Okay. And then of course, and this goes for not just quantitative extraction, but all of your extractions. That this should always be done with the lights on, right? So if you are seeing numbers that don't make sense to you, then it's something to flag, because we've even found errors in the primary studies themselves, where like they have reported a negative standard error, or a p-value that is out of range, or something that we know is clearly a mistake. And so we can't just take everything as it is. We have to make sure that we're always thinking about what we're doing. Okay, next, please. Okay, good. I think now we can share the data form, the
Yep.
Excel file. I just want to, so if you can share that in the chat, which you did, if you could just open it.
Yep.
I just want to orient you a little bit to what we have here. So we've sort of created this fake mini data set, but based on some real data and based on some real challenges that we've had. So what I'm going to ask you to do is essentially put your own detective hat on and try to find some of the problems with this data set. So maybe if you can just zoom in so that at least we're just showing the data itself. So here essentially we're presenting to you just the quantitative pieces of the data that's been extracted. You will often extract multiple effect sizes within one paper, either because there's multiple intervention arms or because there's multiple outcomes reported. And so you'll see that we've grouped them together by authors 1, authors 2, authors 3, and authors 4. So we essentially have 4 papers represented here with various effect sizes for each paper. So a couple of things. I guess one thing I already mentioned as you're playing detective here, as we let you explore the data set, is that I always flag t-values that are over 10, because I suspect that they may not be accurate. And then we go back to the original study and we figure out, it's not always spurious. Sometimes there really is very large t-values, but those are the things that we double check. Standard errors can't be negative. Standard errors always must be positive. So that's another thing that we're always looking out for. If you ever took a statistics class, even like an undergrad, like most basic statistic class, you may remember the t-distribution and the t-table and having to look things up on the t-table. But we know that a t-value has to be 1.96 or higher to be significant. So what we'll also do is we'll look at the t-values in relationship to the p-values. And then on the formula side, we have essentially 2 formulas that we're using here in this document, in this Excel file. So there's one formula, formula 1, which we use when we have exact sample sizes for the treatment and control group separately. And so that's what's happening with author 1. And then we have formula 2, where we use when we only have the total sample size available, which is what's happening in some of the other studies. So we have calculated that for you here. And you can see the formula. They're within the cell. So you can look those formulas up. And then Pierre, I'm going to ask you to also post the 2 things in the run of show, the 2 other resources. So one is converting among effect sizes. So there's a paper. Paper is called Converting Among Effect Sizes, and it gives you all of the information that you need in order to convert between, for example, an odds ratio and standardized mean difference. And then the other thing that I'm asking Pierre to post in here is the Campbell effect size calculator. So if I ever find myself in a position where the formula is not available in the converting among effect sizes paper, then I go to the Campbell effect size calculator. And that's really helpful. It's a really great resource. It's based on a book called Practical Meta-Analysis. And then all of those formula are available there. And you can choose based on the information that you have in your primary study, which is, of course, how you will always select your formula, is based upon the data that you have available to you. Okay, so what I'd like you to do is spend a few minutes playing detective in this particular data set, looking for potential problems and issues. And so hopefully you're able to download this data set. I'll have Pierre leave it up just in case there are some folks that are struggling to download it. But Pierre, I'm gonna say let's do 6 minutes. So at 18 after, just so that we have time to conclude.
Okay, yeah, perfect. So yeah, I've shared the first one, and so the second one.
There's a problem with the link. I'll work
Yeah.
on that while
Yeah, perfect. Thank you.
they're looking at the data set. So yeah, so play detective, highlight any cells that you think might be problematic. And then the Menti for this is going to ask you to identify how many issues or errors, potential errors you found. So it's just going to be a slider bar. And you're just going to put it at the number of errors that you find. So the correct answer is somewhere between 0 and 20. But Pierre, maybe let's put 5 minutes on that Menti, but let's not go back to it until 18 after, just so that folks can come up with all of their own answers.
Yeah, perfect. Yeah, safe. Yeah.
Great. So if you have any questions during the next few minutes, feel free to either speak up or use the chat. Happy to talk through any questions. Okay, so I guess let's first see. We have a couple of peaks here, but they don't show us exact numbers, huh, Pierre? But it looks like less than 10.
Yeah. Yeah.
All right, so let's go back to the data. Yep. And I'm curious if folks can share some of the errors that they found or potential errors, right? Because most of the time we need to go back and look at the original study to see if there really is an issue. But would love to hear someone volunteer one of the potential problems that they found. And you can do it in the chat or yes, negative standard error. Perfect. Perry, you want to highlight that cell? That was an easy one. Yes. We can't make them all too difficult, right? Yes. So there should never be a standard error. And if that is what is in the original paper, then it's problematic. And we would probably contact the author. But maybe it was just a typo from your coder, right? So maybe it actually wasn't negative, it was just a typo. But I would definitely want to look at that some more. What else would we want to look at? Yes, that is an extremely large t-value. I suspect that there is some issue.
Mhm.
Yeah. Yep. Large T-stat positive or negative. So we do have also a really large negative one. Negative 980. So all of these, at this stage, I would be asking my coders to go back to the original studies, and recheck this data. So I think that this particular phase is often undervalued in courses about systematic reviews and in learning about systematic reviews. I think folks often skip from the data extraction to here's how you do the meta-analysis. But if you do that without going through this step of actually reviewing your data, making sure that it looks reasonable, you could be coming up with the wrong answers. And so all of that work would be for naught. Okay, so there's a few more. Any other suggestions?
Yeah, so maybe just say, so someone has put M10, so that's a
Oh,
good
excellent.
point. But so actually the T-stat is fine because it's the ratio of the regression coefficient and standard error. But yeah, the range of the p-value was incorrect based on this p-value. So yeah, that's a good one.
Yeah, excellent work. So and in this case, because we have a t-value, we would actually not use the p-value to calculate standardized mean difference in any way, but it's still a typo. If you're going to share your data set, which is best practice, to make your data set publicly available, then we just want to make sure that it's as good as it can possibly be. Control sample size in R5. Yes, excellent. So I would definitely flag that because it's not often that the control group sample size would be that different between different estimates. Like you may see a fluctuation of a little bit between different outcomes, right? Because maybe there was different amounts of missing data for different measures. So maybe in one outcome it would be 818 and in another outcome it would be 821. But I would be worried about it reducing by almost half. So I would want someone to double check that because I think you're right. I would suspect a copying error. Great. Any others? Yeah, so that p-value one probably should have said p greater than 0.05 in that column, and that was probably just a typo from the coder. M9. I don't think that's one of the ones I flagged.
Yeah,
I think
so
that one's
M9,
okay.
well,
M9.
it's actually a very
Yes,
high,
sorry.
yeah. Yeah, that's
I was
the
looking at
comma.
that's the
Comma
comma
instead of the
issue.
dot, yeah.
Yes, so that person may have had their Excel not in the English version. Great. And then I think because we have a couple of questions to end the program and we are almost at time, I think a couple more that we might flag is the sample size for author 3. So if we have a total sample size and we have a treatment group sample size, then we should have a control group sample size, right? And we would want to use the best available formula. So if we have both the treatment and control group sample sizes, then we would be able to use formula 1 versus formula 2. So I think that's another one to flag. Great. Well, I appreciate everyone playing detective with us, and I do hope that I mean, really, whether you're doing a systematic review or any kind of data analysis, that you take the time to really look at what is reasonable, what the ranges should be. So overall, there was 8 errors, in case anyone's interested in the exact number. But yes, so hopefully you have our email addresses. as part of the sign up, but we can share those if you have any remaining questions. We will just close with a few questions on the Menti to see sort of what you all were able to absorb from today. Thank you so much for joining the session, and yeah, so just a few more to go.
Yeah, so this is three questions that are, so we shared the answer during the session. So just a final opportunity to look at these aspects. So I think we have five minutes left. So let's I mean, I put a 20-second timer, but yeah, you probably will get this right if you were paying attention. But yeah, I guess, yeah, you got that right. I'll stop the timer. So the second question is, yeah, where's the adequate sign of a regression coefficient standard error? Positive, negative, or both? So obviously that's very important. Yeah, and I guess I'll share my, yeah, but it's at the end of the presentation, but yeah, I'll share it again. Share it as well, sorry. Yeah, so it should be positive. It can't be both, it can't be negative. And finally, how do we select the correct formula to, sorry, yeah, that's not written correctly, but yeah, how do we select the correct formula to derive the effect size? So is the formula based on available data? Do we select a formula you're most comfortable with, or do you use a formula that using the combined sample size? So where you have the total sample size, not by treatment and control group. Perfect. Yep. So people who answered always got the right answer, so that's good. And then I think just the final slides is just some resources. So the first one is simply the reference to the systematic review I was presenting, and that we also used in the two exercises, and then some other references on the well, other examples of systematic reviews, and then other ways to, and then toolkits on how to actually do a systematic review. So yeah, they're very valuable links. And then finally, yeah, I guess I'll copy my, in case you need it immediately. Perfect. So I guess, yeah, I'll stop sharing my screen, and thank you. Yeah, thank you very much for joining.
Thank you so much, Pierre and Shannon, for the session. I really appreciate you putting the time into putting this together. I think we all learned a lot about systematic review. And for the participants, you can see they've both put their emails in the chat if you want to follow up with any other questions. And we'll have 3 more days of learning labs for ANH Academy Week 2024. I've put the link to the full program in the chat, so I hope you'll all join us for some more sessions this week.
Thank you so much for having us. Enjoy the rest of the program.
Bye.
Bye-bye.